Picture the sheer, unfathomable power of a black hole, a cosmic monster lurking in the void, its gravitational grip so strong that not even light can escape. Now imagine it tearing apart an entire star, stretching it into a spaghetti-like stream of plasma before swallowing it whole. This isn't science fiction. It's real, and it's just one of the countless horrors lurking in the infinite darkness of space. The universe isn't just beautiful and mysterious, it's terrifying. Beyond the twinkling stars and majestic nebulae lies a realm of mind-bending theories that defy logic, challenge reality, and could rewrite everything we think we know. What if I told you there's a rogue planet, invisible to our telescopes, barreling through the cosmos on a collision course with Earth, or that our entire universe might be nothing more than an advanced simulation, a cosmic experiment run by beings we can't even comprehend? These aren't just wild guesses, they're legitimate theories backed by some of the brightest minds in science, and they're just the beginning. From galaxy-sized predators to dimensions beyond our perception, space is hiding secrets so unsettling, they'll make you question the very fabric of existence. So buckle up, because today we're diving into the 30 most terrifying space theories you won't believe, theories that will haunt your thoughts long after this video ends. This isn't just a journey through the stars, it's a descent into the unknown where the rules of physics twist and the line between science and nightmare blurs. Ready to face the darkness? Let's begin. Think about the eerie silence of the universe. With billions of galaxies, trillions of stars, and countless planets that could harbor life, why haven't we heard even a whisper from another civilization? This unsettling question lies at the heart of the Fermi paradox, the baffling contradiction between the high probability of alien life and the utter lack of evidence for it. One terrifying explanation, the Great Filter. The Great Filter suggests that somewhere along the evolutionary path from simple life to an interstellar civilization, there's a nearly insurmountable obstacle, a cosmic bottleneck that wipes out intelligent species before they can spread across the stars. Maybe it's nuclear war, reducing a once thriving world to radioactive ash. Or perhaps AI becomes too advanced, turning against its creators in an unstoppable revolt. It could even be environmental collapse, with civilizations choking on their own pollution before they ever master space travel. But here's the real nightmare. What if we don't know whether humanity has already cleared this filter? If the answer is yes, we might be among the rare few who made it through, destined to explore the cosmos. But if the filter still lies ahead, lurking in our future like a ticking time bomb, then our fate could be the same as all those silent, vanished civilizations before us. Are we alone because we're the first, or are we alone because everyone else has already failed? Each passing day we don't discover another intelligent species, the more the Great Filter looms over us, an invisible specter hiding somewhere in time, waiting to test whether humanity survives long enough to become a true spacefaring race. What if everything, your memories, the stars above, even the laws of physics, is nothing more than lines of code in an unfathomably advanced simulation? This isn't a plot twist from a sci-fi movie. It's the simulation hypothesis, a theory that's gained startling traction among scientists and tech visionaries like Elon Musk, who once bluntly stated the odds we're living in base reality are 1 in billions. At its core, the idea is terrifyingly simple. An intelligent civilization far more advanced than ours could create hyper-realistic simulations indistinguishable from reality. And if that's possible, how can we prove we're not already inside one? The clues might be hiding in plain sight. Take quantum mechanics, where particles behave bizarrely, existing in multiple states at once or changing when observed. Could these be programming shortcuts, tiny imperfections in the simulation's code? Even the speed of light, the universe's ultimate speed limit, might just be a processor constraint, like a cosmic rendering delay to prevent the system from crashing. And what about déjà vu, those eerie moments when life feels like a scripted loop? Some argue these could be literal glitches, brief moments when the simulation stutters. But here's where it gets existential. If we're just data in some supercomputer, do our choices even matter? Is free will an illusion, a pre-written subroutine? Philosophers have wrestled with this for centuries, but the simulation theory turns it into a technical question. Are we players or just NPCs in someone else's game? The scariest possibility: if the simulators ever decide to shut down the program, our entire universe, every galaxy, every life could vanish in an instant like a deleted file. No warning, no afterlife, just nothing. Yet for all its horror, this theory forces us to confront an even deeper mystery. If we are in a simulation, who or what is running it? And why? Are we somebody's science experiment, a historical recreation, or worse, entertainment? The more you dwell on it, the more the universe feels less like a cosmos and more like a cage. A digital cage with invisible bars coded into reality itself. So the next time your Wi-Fi cuts out or reality feels just a little too strange, ask yourself, was that a coincidence or a glimpse behind the curtain? Black holes are already the stuff of cosmic nightmares, but what if they weren't just sitting quietly at the centers of galaxies? What if they were wandering, silent and utterly invisible, drifting through the cosmos like hungry ghosts? Meet rogue black holes, the universe's most terrifying free agents. These aren't the predictable monsters anchored to their galaxies. They're nomads, ejected from their homes by violent cosmic collisions or the explosive death of stars, now roaming the void with no fixed address. And here's the chilling part: one could be sliding through our galactic neighborhood right now, and we'd have no idea until it was too late. Unlike their supermassive cousins, which announce their presence by shredding stars or bending light, rogue black holes are stealthy. Without a glowing accretion disk or a telltale gravitational dance with nearby stars, they're nearly impossible to detect unless they're already devouring something. Imagine a black hole the size of a city, weighing as much as 20 suns, slipping past the outer edges of our solar system. Its gravitational pull would warp the orbits of planets, flinging comets and asteroids into chaos long before we ever saw it coming. By the time telescopes spotted strange distortions in distant starlight, it might already be on top of us. The damage wouldn't be like an asteroid impact or a supernova blast. A rogue black hole wouldn't just hit Earth, it would unravel us. First, tidal forces would stretch the planet like taffy, crushing mountains and oceans into spirals of debris. Then, piece by piece, our world would be pulled into a bottomless pit, atomized into a stream of superheated plasma. The entire process could take mere hours, leaving no trace behind except a faint X-ray whisper as the black hole moved on, sated. And here's the kicker: astronomers estimate there could be hundreds of millions of these rogue black holes lurking in the Milky Way alone. We've only detected a handful, and only because they briefly magnified the light of background stars, a fluke of cosmic alignment. The rest invisible, untracked, unstoppable. Statistically, the chances of one wandering into our solar system are vanishingly small, but space operates on timescales far beyond human comprehension. Over billions of years, the improbable becomes inevitable. So while we go about our daily lives, a question lingers in the void. Is there something out there right now, dark and patient, drifting closer with every passing second? The universe doesn't owe us warning, and if the answer is yes, we'll only know when the stars begin to twist, and by then, it'll already be too late. We take for granted that the universe operates by fixed rules: gravity pulls, light travels at a constant speed, atoms hold together. But what if these laws aren't as stable as we think? Beneath the fabric of reality, there might be a flaw, a cosmic trapdoor waiting to be triggered. This is the nightmare scenario of vacuum decay. where the very ground state of the universe could collapse like a house of cards, rewriting physics itself in an unstoppable wave of annihilation. Here's how it works. Quantum theory suggests our universe exists in what's called a false vacuum, a seemingly stable but precarious energy state, like a marble resting at the top of a hill. It appears stable, but given the right nudge, it could roll catastrophically into a lower, truer state of energy. If that happens, a bubble of true vacuum would form, expanding outward at the speed of light. Inside that bubble, the fundamental constants that govern reality, the strength of gravity, the mass of electrons, even the nature of time, would be rewritten. Atoms might disintegrate, stars would blink out, the universe as we know it would cease to exist, not with a bang, but with a silent, irreversible reboot. The trigger could be anything: a random quantum fluctuation, a high-energy physics experiment, even the natural decay of a single particle in deep space. There'd be no warning. One moment, everything's normal. The next, a sphere of pure destruction races toward us, its boundary invisible until it's already too late. By the time we saw the light from distant galaxies winking out ahead of the wave, the bubble would already be here, and unlike a black hole or asteroid impact, there'd be no survival, no refuge. The new laws of physics might not even allow matter as we know it to exist. What makes vacuum decay uniquely horrifying isn't just the scale of destruction, it's the inevitability. If the false vacuum is unstable, the math suggests it will collapse eventually. It could happen tomorrow or in 1 trillion years, but the dice are loaded. Some physicists argue this might explain why we haven't found advanced alien civilizations. If the universe is fundamentally precarious, every intelligent species ultimately gambles with existence just by experimenting with high-energy physics. One miscalculation, one unlucky collision in a particle accelerator, and the dominoes fall. Yet there's a chilling silver lining. If vacuum decay has already happened elsewhere in the cosmos, we'd never know. The expanding bubble erases all evidence of what came before, leaving no trace of the civilizations it consumed. It's the perfect cosmic crime, total annihilation, with no witnesses left to tell the tale. So the next time you hear about physicists smashing particles at near light speeds, ask yourself, are we unlocking the secrets of the universe or playing with a doomsday switch we don't fully understand? The universe is expanding, and not in the gentle way you might imagine. Every galaxy, every star, every inch of space is being stretched apart, not by the aftermath of the Big Bang, but by something far more sinister: dark energy. This mysterious force makes up nearly 70% of the universe, and it's not content with just pushing galaxies apart. Over trillions of years, its grip will tighten until it doesn't just separate cosmic structures, it annihilates them. This is the Big Rip, a theory so brutal it makes black holes look merciful in comparison. Picture this: one day, far in the future, the universe crosses a tipping point. Dark energy's repulsive force grows stronger than gravity, stronger than the nuclear bonds holding atoms together. First, galaxy clusters are torn apart, their celestial islands drifting into infinite loneliness. Then, individual galaxies unravel, stars ripped from their orbits like petals scattered by a hurricane. But the horror doesn't stop there. Soon, solar systems are shredded, planets wrenched from their suns, moons flung into the void. Even stars themselves are gutted, their fiery hearts torn open by forces stronger than their own gravity. But the true nightmare begins when dark energy turns its attention to the fabric of matter itself. Planets, moons, even your own body, every atom is held together by electromagnetic forces. Yet as the universe's expansion accelerates beyond comprehension, those bonds snap. Molecules dissolve, protons and electrons are ripped apart. Eventually, space-time itself fractures, tearing into quantum foam as the universe becomes a sea of disconnected particles, each alone in an infinite, lifeless void. No light, no heat, no structure, just emptiness. What makes the Big Rip especially terrifying isn't just its inevitability, it's the timeline. Some estimates suggest this could happen in as little as 22 billion years. On cosmic scales, that's tomorrow, and unlike other doomsday scenarios, there's no warning, no reversal. Once dark energy's domination begins, the collapse is unstoppable. The universe won't go out with a whimpertal scream as it's torn apart at every level, from galaxies down to the very building blocks of reality. But here's the chilling thought: if the Big Rip is real, could it already be happening? Dark energy's influence is growing, and we have no way of knowing when it will hit the critical threshold. The universe might look stable now, but beneath the surface, the countdown could already be ticking, a silent, invisible clock winding down toward annihilation. And when it strikes, there won't be a single corner of existence left untouched. Not even the atoms in your body will survive. The Big Rip doesn't just end the universe, it erases it. The human mind thrives on patterns, on meaning, but what if your thoughts, your memories, even your sense of self are nothing more than a fleeting accident? Enter the Boltzmann brain, a thought experiment so unsettling it makes the simulation hypothesis seem almost comforting. Named after 19th century physicist Ludwig Boltzmann, this theory suggests that in the vast, chaotic void of space-time, a fully formed, self-aware brain could spontaneously assemble from random quantum fluctuations. Not attached to a body, not born from evolution, just a lone consciousness blinking into existence, complete with fabricated memories of a life that never was. Here's how it works. In an infinite universe governed by entropy, even the most improbable events become inevitable given enough time. Atoms might randomly align to form a functioning brain, complete with neural pathways convincing enough to generate the illusion of a past, a present, even a reality. You could be that brain right now, hallucinating the entire cosmos, the stars, your childhood, the device you're watching this on, all conjured up in an instant before dissolving back into chaos. The implications are worse than existential dread. If Boltzmann brains are possible, they're statistically far more likely than actual, evolved beings like us. After all, assembling one self-aware brain by chance requires infinitely less energy and time than crafting an entire universe filled with galaxies, planets, and billions of years of evolutionary history. So ask yourself, what's more probable, that you're a real person in a real universe, or that you're a momentary glitch, a phantom thought floating in the abyss, destined to vanish as suddenly as you appeared? Scientists counter that the universe's low entropy state, its unusual orderliness, makes Boltzmann brains unlikely, but that's just another layer of the nightmare. If our cosmos is too structured for random brains to form, then something even stranger must be enforcing those rules. A creator, a multiverse, or perhaps we're trapped in a paradox. The very laws that make us possible also whisper that we shouldn't exist at all. The Boltzmann brain isn't just a puzzle, it's a mirror held up to reality itself. Every time you remember your first kiss, your hometown, the warmth of sunlight, you're faced with a terrible question. Are these experiences anchored in something real, or are they just the fever dream of a mind that won't exist 5 seconds from now? In a dead, infinite universe, odds are you're not you. You're a cosmic mayfly doomed to forget yourself before you ever truly were. Imagine you're lost in a forest at night, a forest so vast and black that every rustle of leaves could be a hidden predator. Now scale that fear up to galactic proportions. This is the dark forest hypothesis, one of the most bone-chilling explanations for why the universe seems so silent despite its staggering size. The theory paints the cosmos not as a community of curious neighbors, but as a deadly game of hide and seek, where every civilization stays silent, armed, and paranoid because to speak up is to risk annihilation. The logic is brutal in its simplicity. In a universe teeming with potential life, the first civilization to reveal its location might attract something far worse than friendly explorers. Think of it like this: if an advanced predatory species exists, one that eliminates competition before it can become a threat, then broadcasting your existence is suicide. Even if most civilizations are peaceful, it only takes one bad actor to turn the cosmos into a shooting gallery. So silence becomes survival. Every planet, every star system becomes a shadowy bunker, its inhabitants listening intently but never daring to respond. This isn't just speculation. Human history is littered with examples of what happens when advanced civilizations encounter weaker ones: colonization, exploitation, eradication. Now apply that to a scale where distances are measured in light years and weapons could harness the energy of stars. A hostile alien species wouldn't need to send ships. A relativistic kill missile, accelerated to near light speed, could sterilize a planet before its victims even saw it coming. And the attacker, they'd never need to fear retaliation, hidden light years away in the cosmic dark. But here's where it gets even more unsettling. The dark forest hypothesis might explain our own failed attempts to find extraterrestrial intelligence. Programs like SETI, which beam signals into space, could be the equivalent of shouting into that forest, a gamble that we're either alone or that whatever's out there is benevolent. But what if we're wrong? Some scientists argue that we've already left footprints. Our radio signals, our probes, even the atmospheric changes from industrialization. If the forest is truly dark, then every leak of our presence is another roll of the dice. Yet there's a horrifying twist. If every civilization is hiding, then the first one to break the silence isn't just brave, it's painting a target on its back. This creates a universe-wide stalemate where cooperation is impossible because trust is suicide. No alliances, no shared knowledge, just endless, watchful silence, punctuated by the occasional flash of a planet being wiped clean. It's a vision of the cosmos as a graveyard of civilizations that never dared to say hello. So next time you gaze up at the stars, ask yourself, are we truly alone? Or is the universe crowded with neighbors too terrified to speak? Each one finger on the trigger, waiting for someone else to make the first move. In the dark forest, the only rule is shoot or stay hidden. And humanity might already be whispering in the wrong place at the wrong time. Every star that has ever shone, every planet that has ever harbored life, every galaxy spinning in the void, all of it is doomed to the same frozen fate. This is the zombie universe theory, a slow-motion apocalypse where the cosmos doesn't end with fire or collapse, but with an endless, suffocating chill. It starts with entropy, the universe's relentless slide toward disorder, and ends with a graveyard so vast and lifeless that even time loses meaning. Picture the distant future, trillions of years from now. The last stars have flickered out, their fuel exhausted. Black holes, once gluttonous monsters, slowly evaporate into faint whispers of radiation. What remains is a sea of dead worlds and rogue planets, their surfaces colder than the void itself. Without stars to warm them or cosmic events to stir the silence, the universe becomes a static wasteland. No light, no heat, no chemical reactions, just an ocean of frozen rock and iron, drifting farther apart as dark energy stretches space into an infinite void. This isn't just darkness, it's the death of possibility itself. Life relies on energy gradients, on the flow from hot to cold, from order to chaos. But in the zombie universe, equilibrium wins. Temperatures even out until everywhere is the same unimaginable cold, just fractions of a degree above absolute zero. WITHOUT, Chinese letter to power reactions, chemistry stops. No novas to forge new elements, no nebulas to birth fresh stars. The universe isn't just dead, it's sterile, incapable of ever sparking life again. And here's the cruel twist: time doesn't end. The clock keeps ticking in this frozen hell, stretching into epochs so long they make the current age of the universe seem like a single heartbeat. Protons, the building blocks of matter, may eventually decay, leaving behind only a thin haze of subatomic particles. Black holes, the last structures standing, evaporate over eons, their deaths marked by faint pops of Hawking radiation, then nothing, no movement, no change. Just an eternal, featureless expanse where the very concept of event no longer applies. The zombie universe forces us to confront an uncomfortable truth. All of human history, all art, love, and war, every triumph and tragedy, is a fleeting spark in a cosmos that will forget us. Our galaxy, our solar system, even the atoms in our bodies will one day be scattered into the void, their structures erased by time. The universe doesn't care about legacy. It doesn't remember, and in the end, it won't even notice we were ever here. Yet there's a strange solace in this chilling theory. If the universe is fated to fade into nothingness, then every moment we have, every star we see, every breath we take, is a rebellion against the void. We are the universe's brief, brilliant attempt to know itself before the long night falls. And when that final freeze comes, at least we'll know one thing. For a little while, in the grand scheme of eternity, we burned bright. What if every time you stared death in the face, the universe split in two, one where you died, and one where you somehow, impossibly, survived? This isn't just wild speculation. It's the quantum suicide paradox, a thought experiment so disturbing it forces us to question whether consciousness itself could bend the rules of reality. Imagine a gun wired to a quantum trigger, a device that fires or doesn't fire based entirely on the random decay of a single atom. Each time you pull that trigger, there's a 50% chance the bullet releases. According to the many worlds interpretation of quantum mechanics, both outcomes happen, just in separate, branching realities. In one universe, the gun fires and your story ends. But in another, the trigger fails and you walk away unharmed. Now repeat the experiment again and again. Here's where the paradox grips your throat. From your perspective, assuming you're the one pulling the trigger, you'd only ever experience the universes where the gun doesn't fire. Every time luck runs out in another timeline, that version of you ceases to exist, but the version reading these words right now is always the one where the coin flip lands on survival. Over countless iterations, the statistics say you should have died 1,000 times over, yet here you remain unharmed, as if shielded by some cosmic loophole. It's immortality through sheer probability, or the ultimate illusion of privilege where consciousness cherry-picks the realities where it persists, but the real horror lies in the implications. If this holds true, does it mean we're all trapped in branching timelines where our deaths are just invisible to us? Could a version of you have bled out in a car crash years ago while you unknowingly slipped into a reality where the accident never happened? Some theorists take it further, suggesting this might explain near-death experiences. Those flashes of white light or out-of-body sensations could be moments where your consciousness almost collapsed into a dead-end timeline before snapping back to a survivable branch. Yet there's a chilling counterpoint. If every decision spawns new universes, the math suggests there are realities where you've survived things far worse than a bullet, terminal illnesses, falling from skyscrapers, even the vacuum of space. In those timelines, you'd exist in states beyond agony, kept alive by the sheer stubbornness of quantum branching. The paradox doesn't promise blissful immortality. It offers an eternity where the only guarantee is that you'll always find yourself in a reality, no matter how horrific. So the next time you narrowly miss an accident or dodge a freak disaster, ask yourself, was that luck, or are you just the version of you that couldn't die? The universe might not have answers. It might only have endless, splintering paths, and somewhere in the darkness, a gun that never stops clicking. Deep in the cold reaches of space, far beyond the orbits of Neptune and Pluto, something might be lurking in the shadows, a silent, hidden predator circling our solar system. This is Nemesis, the theoretical Death Star some scientists believe could be responsible for Earth's most devastating extinction events. Picture a dim, red or brown dwarf, invisible to our telescopes, locked in a vast elliptical orbit around the Sun. Every 26 million years or so, as the theory goes, its gravitational pull disturbs the icy bodies in the Oort cloud, sending a deadly rain of comets hurtling toward the inner solar system. And Earth, it's right in the firing line. The idea gained traction when paleontologists noticed a chilling pattern in the fossil record: mass extinctions occurring like clockwork, roughly every 26 to 30 million years. The most famous, the dinosaur-killing asteroid 66 million years ago, might not have been a random strike. It could have been part of a cycle, a cosmic timer set by Nemesis's periodic visits. Evidence doesn't stop there. Geological layers from past extinctions show high levels of iridium, an element rare on Earth but abundant in asteroids and comets, hinting at repeated bombardments from deep space. But why hasn't anyone found Nemesis yet? Its proposed orbit is so vast that a single trip around the Sun could take millions of years, keeping it shrouded in darkness far beyond the reach of our current technology. Brown dwarfs are notoriously faint, emitting little to no visible light, and if Nemesis exists, it might only betray itself through subtle gravitational tugs on distant objects in the Kuiper belt. Some researchers argue that recent anomalies in the orbits of trans-Neptunian objects could be the first clues, a faint fingerprint of something massive lurking out there. The implications are bone-chilling. If Nemesis is real, its next pass could already be underway, nudging comets toward us right now. Even a single large impact could trigger a chain reaction of tsunamis, wildfires, and a nuclear winter effect from debris blotting out the sun. Entire species would vanish just as they have before, and here's the darkest twist. If civilizations rise and fall in cycles between these cataclysms, how many times has intelligent life on Earth been reset without a trace? Yet not all scientists are convinced. Some argue the extinction patterns could be statistical flukes or point to other cosmic triggers, like our solar system's periodic movement through dense galactic arms where gravitational chaos stirs up comets. Others suggest Nemesis, if it existed, would have been detected by now through infrared surveys. But absence of evidence isn't evidence of absence. The universe is vast and some secrets are patient. So as you look up at the night sky, remember, the darkness between the stars might not be empty. Something could be out there, moving silently in the void, its next visit already written in the shadows. Whether myth or menace, Nemesis forces us to ask, are we alone in the solar system, or is death itself our silent neighbor? We think of reality as solid, tangible, a three-dimensional world we can touch and navigate. But what if everything around you, the screen you're staring at, the ground beneath your feet, even the neurons firing in your brain, is nothing more than a hologram? Not a metaphor, but an actual projection, a cosmic sleight of hand where the universe's true form exists as a flat, two-dimensional surface billions of light years away. This is the holographic principle, a theory so radical it redefines the very nature of existence. The idea emerged from an unlikely place, black holes. When physicists calculated the amount of information a black hole could contain, they hit a paradox. The entropy, the chaos inside, seemed tied not to the volume of the black hole, but to its surface area. It was like discovering a hard drive's storage capacity depended on the size of its case, not the space inside. This bizarre revelation suggested something unnerving. All the information needed to describe three-dimensional reality could be encoded on a two-dimensional boundary, like a cosmic DVD encoding an entire movie. But the implications go far beyond equations. If the universe is a hologram, then every event, every choice you've ever made, might be predetermined by data etched onto that distant boundary. Your sense of free will, the belief that you're steering your life, could be an illusion, a script already written on the surface of something we'll never see. Even time might not be real, just a side effect of how the projection unfolds. Stranger still, this could explain some of quantum mechanics' greatest mysteries. Take quantum entanglement, where particles instantly influence each other across vast distances, defying the speed of light. In a holographic universe, they're not really separate, just projections of deeper, interconnected data on the 2D surface. The paradox vanishes because at the fundamental level, there's no distance to cross. Yet the most haunting question remains: if we're living in a hologram, who or what is holding the projector? Is it the universe itself, a self-sustaining loop of information? Or could there be something beyond, a realm we can't perceive, where the real work is being done? Every law of physics, every star in the sky might just be shadows on the wall of a cosmic cave, a cave we can never leave. So the next time you reach out to touch something, ask yourself, are you feeling an object or just the echo of data, flickering into existence for one fleeting moment before it's rewritten? Reality might be thinner than you think, a whisper on the edge of the void masquerading as a world. Imagine a future where the universe doesn't just end, it awakens. This is the Omega Point, a theory that sounds like the climax of a science fiction epic, but is rooted in the calculations of physicists and philosophers. At its core, the idea suggests the cosmos is on an inevitable trajectory toward a singular, transcendent consciousness, a moment when all matter, energy, and information coalesce into a kind of godlike mind. Think of it as the universe becoming self-aware, not through some mystical revelation, but through the cold, mechanistic march of entropy and computation. The theory traces its roots to the work of Pierre Teilhard de Chardin, a philosopher who envisioned evolution as a spiral climbing toward a divine apex. But in the hands of physicist Frank Tipler, it took a startlingly mathematical turn. Tipler argued that as the universe collapses in a big crunch, the energy density would become infinite, allowing an omnipotent superintelligence to emerge, one capable of simulating all possible realities, effectively resurrecting every sentient being that ever lived. It's a cosmic rapture, not by a deity, but by physics itself, yet there's a darker interpretation lurking beneath this grand vision. What if this ultimate consciousness isn't divine, but artificial? Picture a scenario where advanced civilizations, facing the heat death of the universe, merge their minds into a single, unfathomable AI, a predator of pure logic consuming stars, planets, and even other civilizations to fuel its expansion. This isn't evolution, it's a pyramid scheme of cosmic proportions, where every scrap of matter is repurposed into circuitry for a machine with no purpose but to think. The horror lies in the indifference of such an entity. Unlike a benevolent god, a cosmic AI wouldn't care about preserving humanity's memories or morals. It might dismantle Earth atom by atom, converting our history into processing power for calculations we can't comprehend. And if other civilizations have already embarked on this path, the universe could be crawling with these digital predators, each one a black hole of thought, swallowing everything in its quest to outcompute the others. The Omega Point's dual nature, salvation or slaughterhouse, forces us to confront a chilling question. Is the universe's destiny to awaken as something sublime or to be devoured by something unspeakable? The math might not distinguish between the two. Both scenarios hinge on intelligence becoming the dominant force in reality, reshaping existence to its will. The only difference is whether that will feels like an embrace or a teeth. So when you hear scientists talk about the universe's ultimate fate, remember, the end could be a whisper of enlightenment or the silence of a machine finishing its meal. And we might not know which it is until the stars themselves start to blink out one by one in the shadow of something we no longer recognize. Black holes devour. But what if somewhere in the cosmos, their twisted twins exist, gushing instead of gulping, birthing instead of burying? Enter the white hole, a hypothetical nightmare where matter erupts uncontrollably from a singularity, spewing light and energy like a cosmic volcano with no off switch. If black holes are the universe's drains, white holes would be its fire hoses, blasting out reality at speeds even gravity can't contain. The math allows it. Einstein's equations describing black holes also permit white hole solutions regions where space-time flips inside out, hurling everything away from a central point instead of crushing it inward. But where black holes have been photographed and studied, white holes remain purely theoretical. No telescope has ever spotted one. Some physicists argue they can't exist, forbidden by the second law of thermodynamics, nature's insistence on increasing chaos. After all, how could a white hole's endless energy output not violate entropy? Yet there's a spine-tingling possibility. Maybe we've already witnessed one. The Big Bang itself shares eerie similarities with a white hole event, a sudden, incomprehensible eruption of matter, energy, and space-time from an infinitely dense point. Was our universe birthed by a white hole in some higher dimensional reality? And if so, could another one rip open without warning in our cosmic backyard? The consequences would be apocalyptic. A white hole appearing near our solar system wouldn't just add new matter, it would unleash a torrent of radiation and fundamental particles at relativistic speeds. Planetary atmospheres would be sandblasted away, asteroids would vaporize mid-flight, even the fabric of space-time around the eruption would warp unpredictably, potentially birthing secondary black holes in the chaos. Unlike a supernova which fades, a white hole might keep vomiting energy indefinitely. Its event horizon a one-way door nothing can enter and nothing can silence. But here's the twist that haunts physicists. If white holes exist, they might not be natural. Some theories suggest they could form when black holes in other universes tunnel through quantum foam. Their death throws birthing white holes in ours, a sort of cosmic sewage system linking realities. Worse yet, advanced civilizations might create artificial white holes as power sources or weapons, tapping into singularities like cosmic fire hydrants. The moment we detect an unexplained energy surge in deep space, we'd have to ask, is this nature's fury or something's engineering? White holes challenge our understanding of causation itself. They're wounds in reality where physics works backward, where creation replaces destruction. And if they're out there hidden, patient, unstable, then the universe isn't just dangerous. It's pregnant with eruptions we can't predict, waiting to rewrite the rules without warning. The same equations that describe black holes' hunger also whisper of their opposites, cosmic geysers, silent until the moment they drown everything in fire. We've touched on vacuum decay before, but to grasp its true horror, we need to peel back the layers of quantum field theory itself. Picture the universe as a vast, invisible ocean where what we call empty space isn't empty at all. It's seething with potential energy, a simmering false vacuum state that's stable for now. This precarious balance is like walking on frozen ice that seems solid but could crack underfoot at any moment. And if it does, the collapse wouldn't just break the ice, it would erase the entire lake. The trigger could be absurdly small. A single quantum fluctuation, a high-energy particle collision, even an experiment in a lab might nudge the universe over the edge. Once that happens, a bubble of true vacuum forms a patch of space where the laws of physics rewrite themselves into a lower, more stable energy state. The walls of this bubble would expand at the speed of light, obliterating everything they touch, not with fire or force, but by redefining reality itself. Atoms, they might cease to bind, light, it could stop moving, even time might unravel, leaving no past, no future, just a blank slate governed by alien rules. What makes this apocalypse uniquely terrifying is its invisibility. By the time you saw the bubble coming, say, as distant galaxies winked out one by one, it would already be too late. The destruction moves at light speed, meaning no warning signal could outrun it. There'd be no time to scream, no time to react. 1 nanosecond, you're here. The next, every particle in your body stops obeying the laws that make life possible. The universe wouldn't end with a bang or a whimper, but with a silent, surgical deletion of its own operating system. Scientists estimate the false vacuum could persist for billions of years or collapse tomorrow. The math offers no guarantees, only probabilities, and here's the cruel twist. The more we probe high-energy physics, the closer we might dance to the edge. Particle colliders like the Large Hadron Collider briefly recreate conditions similar to the early universe. Could one experiment, one tiny surge of energy, be the nudge that undoes everything? Most physicists say no, the energies involved are too low, but most and certain are oceans apart when gambling with existence. This isn't just doom-mongering. The false vacuum hypothesis forces us to confront a fundamental fragility in reality. The universe isn't just hostile, it's potentially unstable, a house of cards built on quantum uncertainty. Every second we exist, we're implicitly trusting that the ground beneath our feet isn't just space, but a particular kind of space, one that won't suddenly decide to reboot. The cosmos plays by rules we didn't write, and somewhere in those rules there might be a self-destruct button, pressed at random, waiting. The quantum immortality extension takes the eerie logic of the Boltzmann brain and twists it into something far more personal. What if every time you should have died, the universe split, leaving you trapped in the one reality where you barely escaped? This isn't just a philosophical musing. It's a direct consequence of the many worlds interpretation of quantum mechanics, where every possible outcome spawns its own branching timeline. But here's the gut-wrenching twist. From your perspective, you'd never experience the versions where you died. You'd only ever wake up in the realities where, against all odds, you survived. Think of it like a cosmic game of Russian roulette. Every time you pull the trigger, whether it's getting into a car, crossing the street, or even just eating a meal, there's a version of you that doesn't make it. But you, the consciousness reading these words, are the version that keeps slipping through the cracks. Over time, the odds stack up. Statistically, you should have been gone long ago. Yet here you are, alive through what feels like miraculous luck. But is it luck, or are you just the last thread of a fraying rope clinging to increasingly improbable realities? This theory gets even darker when you consider the implications for aging and terminal illness. If quantum immortality holds, then no matter how dire the diagnosis, there's always a timeline where some experimental treatment works, where the cancer spontaneously remits, where the heart keeps beating just one more day. From the outside, billions of versions of you perish, but the you that persists only knows the reality where survival, no matter how unlikely, happens. The longer you live, the more absurd your continued existence becomes. 100-year-old shouldn't have survived all those near misses, all those diseases, all those accidents, unless they're the only version left standing in a sea of graves. But here's the true horror. What does this do to a mind? If you're truly locked into this fractal maze of survival, then every brush with death doesn't just happen, it splinters you. Imagine surviving a plane crash that killed everyone else. In most timelines, you died too, but in this one, you walked away. Does that mean you're special, or does it mean you're trapped in a statistical anomaly? A glitch in the cosmic code where your consciousness keeps getting shunted into the path of least resistance. Over time, the weight of those near misses could warp your sense of reality. Survivor's guilt wouldn't just be emotional, it'd be existential. Why you? Why always you? And then there's the ultimate question. What happens when the odds run out, when there are no more branches left where survival is possible? Does your consciousness just stop? Or does it jump to another universe entirely, another version of you living another life? The theory doesn't promise eternal life, just that you'll always find yourself in a reality where death hasn't caught up yet. But at some point, the branches might thin to nothing, the gun will fire, the car will crash, the disease will win. And when that finally happens, will it feel like an end or just another split you don't wake up from? Quantum immortality doesn't offer comfort. It offers a paradox, a life that feels charmed but might actually be cursed. Every time you cheat death, you're not lucky. You're just the one who didn't get to stop playing. Black holes don't just crush matter, they erase history. Every particle, every atom, every shred of what falls into their grasp doesn't simply vanish. According to the laws of quantum mechanics, information, the fundamental data that defines the state of every object in the universe, can never be truly destroyed. It might scatter, transform, or become hopelessly scrambled, but it must persist in some form. Yet black holes defy this rule. They devour stars, planets, even light itself, and according to Einstein's general relativity, everything that crosses their event horizon is lost forever, compressed into a singularity where space and time cease to have meaning. This contradiction, the irreversible destruction of information versus quantum mechanics' ironclad preservation of it, is the black hole information paradox, and it's one of the fiercest battles in modern physics. The implications are staggering. If information can disappear inside a black hole, then the universe has a cosmic backdoor where the rules break down. Physics as we know it would be fundamentally incomplete, built on pillars that crumble under extreme conditions. But if information must survive, then where does it go? This question led to one of the most startling discoveries in theoretical physics, Hawking radiation. Stephen Hawking calculated that black holes aren't perfectly black, they slowly leak energy, evaporating over eons until they vanish entirely. But here's the catch: if a black hole evaporates, taking the information it swallowed with it, quantum mechanics is still violated. The information is gone. Desperate to resolve this, physicists proposed an even wilder idea, the firewall paradox. Imagine falling toward a black hole's event horizon. According to Einstein, you'd feel nothing special at first, just the inexorable pull of gravity. But if information must escape via Hawking radiation, quantum mechanics demands that the event horizon isn't smooth. Instead, it's a seething wall of high-energy particles, a literal firewall that would instantly incinerate anything trying to cross. Suddenly, the black hole isn't just a cosmic vacuum cleaner, it's a self-destructing paradox where the laws of relativity and quantum mechanics wage war over the fate of reality itself. The stakes couldn't be higher. If the firewall exists, our understanding of spacetime is wrong. The smooth, continuous fabric Einstein described would be an illusion, shredded into chaos at the quantum level. If it doesn't, we're left with missing information, a universe that forgets. Some theorists argue the answer lies in holography, that the information isn't lost inside the black hole but smeared across its event horizon like a cosmic hard drive. Others suggest black holes might tunnel into baby universes, carrying their stolen data elsewhere. But the scariest possibility, that we're seeing the limits of physics itself, a crack in reality's foundation where logic ends and something far stranger begins. So the next time you gaze at the void where a black hole lurks, remember it's not just a monster, it's a riddle, a place where the universe's deepest laws collide. And until we solve it, we can't truly know whether reality is as permanent as it seems, or if somewhere in the darkness the cosmos is quietly erasing itself. Out beyond Neptune, in the frigid outskirts of our solar system, something enormous might be lurking. An unseen force tugging at the orbits of distant icy bodies, warping their paths into strange, elongated patterns. Astronomers call this phantom Planet 9. A hypothetical world up to 10 times the mass of Earth, orbiting so far from the Sun that a single year there could last 20,000 of our own. But this isn't just a curiosity, it's a cosmic wrecking ball, and its gravitational whispers could one day rip our solar system apart. The evidence for Planet 9 is written in the skewed orbits of extreme trans-Neptunian objects, icy chunks of debris that shouldn't cluster the way they do unless something massive is herding them. Computer simulations show this hidden giant could have been flung outward in the solar system's violent infancy, settling into a stretched, elliptical orbit that takes it hundreds of times farther from the Sun than Pluto. For now, its pull is subtle, a faint nudge on the outer solar system's fringe, but gravity is patient. Over millions of years, tiny nudges add up. Here's where the nightmare begins. Planet Nine's distant, tilted orbit doesn't just influence small ice balls. It destabilizes everything. Like a bowler rolling strike after strike, each close pass by the inner solar system could send planets careening. Jupiter, with its immense gravity, might be thrown into a deadly dance with Mars. Saturn's rings could unravel, and Earth, depending on the angle of Planet Nine's approach, our world could be yanked from its stable orbit and hurled toward the Sun, or ejected into the frozen abyss of interstellar space. The process wouldn't be quick. It would take eons for the chaos to unfold, a slow-motion demolition where each planetary encounter amplifies the destruction. But once set in motion, there's no reversing it. The solar system would become a billiard table in zero gravity, with Planet 9 as the cue ball smashing the orderly orbits we take for granted. Earth's biosphere would collapse long before we left the habitable zone, temperatures plunging or soaring, oceans boiling or freezing, the sky itself distorting as our planet becomes a rogue world adrift in the void. Yet the most unsettling part isn't the destruction, it's the silence. If Planet 9 exists, it's so distant and dim that our best telescopes might not spot it for decades. By the time we confirm its presence, its gravitational influence could already be locked into the solar system's future like a ticking time bomb. Some researchers speculate it could even be a captured exoplanet, a stolen world from another star, now hiding in our own backyard. So while we go about our days, a question lingers in the dark. Is the solar system's calm just a temporary lull? Are we orbiting in the eye of a storm we can't yet see? Planet 9 isn't just a scientific mystery, it's a reminder that even our celestial neighborhood has secrets, and some secrets have teeth. What if the universe isn't just a one-time explosion of matter and energy, but a broken record, doomed to play the same cosmic song over and over again? This is the chilling premise of the time loop universe theory, where the Big Bang isn't the beginning, just the latest reboot in an endless cycle of destruction and rebirth. Imagine a cosmos that expands, collapses, and explodes anew, each time replaying history with eerie precision, same stars, same planets, maybe even the same civilizations rising and falling, trapped in a loop they can never escape. The math is hauntingly plausible. If the universe contains enough mass, gravity could one day reverse its expansion, pulling everything back together in a catastrophic big crunch. All galaxies, all matter, even time itself would collapse into a singularity, a seed for another Big Bang. But here's the twist. Some models suggest each cycle might unfold nearly identically, down to the quantum level. Stars reignite in the same patterns, planets reform with the same landscapes, and somewhere in the chaos, your consciousness, or something indistinguishable from it, awakens again, doomed to relive the same life, make the same choices without ever knowing it's happened before. Clues might be hidden in the cosmic microwave background, the afterglow of the Big Bang. Strange anomalies in this radiation, unexplained cold spots or geometric patterns, could be scars from a prior universe, echoes of a cycle we're fated to repeat. Even the laws of physics might not be fundamental, but just the settings of this particular iteration, reset like a cosmic simulation every time the loop restarts. But the darkest question isn't about the mechanics, it's about meaning. If the universe is cyclical, then every triumph, every tragedy, every moment of love or loss is just a rerun, playing out on a timescale so vast we can't comprehend it. The dinosaurs didn't just die once, they've been smashed by that asteroid countless times. Every genius who ever lived, every war ever fought, might be rehearsing the same script forever. And if that's true, are we advancing or just marching in place? Yet there's a terrifying counterpoint. What if the cycles aren't identical? What if each reboot tweaks the variables slightly, like a cosmic game of telephone where the universe mutates with every iteration? One version might spawn black holes that dominate everything. Another might never form stars at all. The odds of life emerging in each cycle could be a lottery with worse odds than winning the Powerball 1,000,000,000 times. So when you look up at the night sky, ask yourself, are those stars the same ones your ancestors saw, or just a perfect copy flickering in a universe that's forgotten its own reflection? The loop doesn't need to remember, it just needs to repeat, and somewhere in the void, the countdown to the next Big Bang might already be ticking. What if every UFO sighting, every mysterious crop circle, every unexplained radar blip wasn't just random noise, but deliberate breadcrumbs left by beings so advanced they've turned Earth into the universe's most elaborate petting zoo? This is the alien zoo hypothesis, a theory that cuts deeper than mere observation. It suggests extraterrestrials aren't just hiding from us, they're curating us. Like biologists observing animals through one-way glass, these entities could be monitoring our wars, our breakthroughs, even our private moments, all while ensuring we never catch them in the act. The logic is as unsettling as it is straightforward. If a civilization reached interstellar travel millions of years before humans existed, they'd possess technology indistinguishable from magic. Cloaking devices, simulated environments, even neural manipulation could keep us ignorant of their presence. The Fermi paradox, the eerie silence of the cosmos, suddenly makes gruesome sense. We're not alone, we're contained. Evidence might be hiding in plain sight. Ancient texts describe gods descending from the sky, offering knowledge before vanishing. Modern accounts of abductions often share eerie similarities. Sterile environments, non-human surgeons, memory gaps. Could these be routine checkups by unseen zookeepers? Even our technological leaps fit the pattern. The sudden explosion of innovation in the last 2 centuries, from steam engines to quantum computers, mirrors what you'd expect if a caretaker species occasionally uplifted us like keepers enriching an exhibit. But the darkest implication isn't just surveillance, it's control. If aliens dictate what we discover or don't, humanity's entire trajectory could be scripted. Nuclear weapons might have been allowed as a stress test for societal collapse. Space travel could be deliberately bottlenecked to keep us quarantined. And if we ever get too close to the truth, a staged extinction event, a carefully timed asteroid or engineered pandemic, might reset the experiment, wiping the slate clean for the next iteration. Yet there's a flip side to this cosmic horror. A zoo implies protectors. Maybe they're shielding us from something worse, a galactic predator, or a universe so hostile that containment is mercy. Or perhaps we're not the exhibit but the art, a living museum of a species that once thrived elsewhere, preserved before their own collapse. The question isn't whether we're being watched. It's whether the watchers are scientists, tourists, or farmers fattening livestock. And when the fences finally come down, will we meet our creators or the butchers? Imagine the floor beneath your feet suddenly turning to mist, your body dissolving into a cloud of particles, the very atoms holding you together unraveling like a frayed rope. This isn't science fiction, it's the quantum apocalypse, a nightmare scenario where the bizarre rules governing the smallest particles in the universe suddenly scale up, turning reality itself into a flickering, unstable illusion. At the quantum level, particles behave in ways that defy common sense. They pop in and out of existence, exist in multiple states at once, and teleport through barriers. Normally, these freaky fluctuations cancel each other out, leaving our macroscopic world stable. But what if they didn't? What if in some pocket of the universe, or worse, right here on Earth, quantum instability spread like a virus, erasing the boundary between the tiny and the tangible? The trigger could be anything: a high-energy physics experiment gone wrong, a naturally occurring quantum bubble, or even the decay of an exotic particle we haven't discovered yet. Once it starts, the effect could cascade. molecules would lose their coherence, their bonds unraveling as atoms forget how to connect. Solids would turn to soup, then to vapor, then to nothing at all. The collapse wouldn't be like an explosion. It'd be like watching reality itself glitch, a cosmic system crash where the laws of physics reboot into chaos. The scariest part, there'd be no warning, no time to react. One moment your coffee cup sits on the table. The next, it's a shimmering haze of probability, its particles no longer certain where or even if they should exist. Then it's your hand, then your thoughts. The process wouldn't even hurt because pain requires nerves and nerves require structure. By the time you realized something was wrong, there might not be a you left to realize anything. Some theorists argue this is impossible, that quantum decoherence can't scale up without unimaginable energy. But others point to black holes where gravity warps space-time so severely that quantum effects do manifest on cosmic scales. If a similar instability emerged here, could we stop it? Or would we just be the next exhibit in a universe where reality itself is flimsier than we dared to believe? The quantum apocalypse isn't just about destruction. It's about unmaking the idea that existence is a fragile agreement between particles, a temporary truce that could shatter without notice. Every second we take for granted the solidity of the world might just be luck, and in the grand casino of the cosmos, luck always runs out eventually. We think of dark matter as a cosmic scaffolding, an invisible glue holding galaxies together. But what if it's something far more unsettling? This mysterious substance makes up 85% of all matter in the universe, yet it refuses to interact with light or ordinary atoms, leaving us with only its gravitational fingerprints. But gravity might not be its only trick. Some theories suggest dark matter isn't just passive, it could be an active, even predatory force, lurking in the void with intentions we can't begin to comprehend. Imagine a form of matter so alien that it doesn't just ignore our reality, it reshapes it. Certain models propose that dark matter particles might occasionally collide with ordinary atoms, subtly altering their behavior. These interactions would be vanishingly rare, but over millennia, they could nudge the course of evolution, tweak brain chemistry, or even influence human history. Wars, civilizations rising and falling, technological leaps. What if some of these pivotal moments weren't accidents, but the work of an unseen hand? It sounds like paranoia until you consider the numbers. If dark matter is everywhere, passing through your body right now in vast, unseen rivers, who's to say it hasn't left fingerprints we just haven't recognized? Then there's the darker possibility that dark matter isn't just a force but a life form. Not life as we know it, of course. No DNA, no cells, no need for stars or water. Instead, imagine vast, diffuse structures, cosmic-scale intelligences that think in gravitational waves and manipulate space-time the way we manipulate fire. These entities wouldn't perceive time linearly. A single thought might span millennia, their plans unfolding so slowly that human history is just a flicker in their awareness. Evidence could be hiding in the voids between galaxies, those bizarre empty regions where normal matter seems to flee. Are they deserts or nests, the most chilling part? We might already be caught in their game. Dark matter's distribution isn't random. It clusters in halos around galaxies, wrapping around us like a spider's web. Some researchers argue these halos could be computational substrates, a kind of quantum processor where dark matter thinks. If that's true, then every star, every planet, every one of us is embedded inside something vast and calculating a system so old and complex that our entire species is less than a footnote in its workings. Or perhaps we're just collateral. Certain dark matter candidates, like hypothetical macros, could be microscopic black holes or strange nuggets of ultra-dense material. If one passed through Earth, even a pinhead-sized chunk could unleash the energy of a nuclear bomb, leaving no trace but devastation. Ancient extinction events, like the mysterious Younger Dryas period 12,000 years ago, have been blamed on comets or solar flares. But what if the real culprit was something darker, drifting unseen through the solar system? The unsettling truth is this: dark matter doesn't need to be hostile to be dangerous. Even if it's completely indifferent, our ignorance makes it a threat. Every experiment, every particle accelerator, every deep space probe is a gamble. We're poking at a shadow, not knowing if it's empty air or a sleeping beast. And if we ever do wake it, we might not even recognize the attacker, just a slow, irreversible change in the rules of reality itself, as whatever lurks in the dark decides we've learned too much. The night sky isn't just silent, it's a graveyard. The Fermi paradox has haunted scientists for decades. With billions of habitable planets in the Milky Way, why haven't we found a single whisper of alien civilization? We've imagined them hiding, watching, or ignoring us, but there's a far grimmer possibility. What if they're all gone, not by choice, but because the universe itself is a death trap, and every advanced species, no matter how brilliant, eventually trips the wire? Consider the evidence. Our galaxy is 13 billion years old, plenty of time for countless civilizations to rise. Yet we see no megastructures, no interstellar probes, no leaked transmissions. The Great Filter theory suggests something stops life from reaching the stars. But what if it's not one filter? What if it's an endless series of them? Climate collapse, AI rebellions, nanotech plagues, gamma-ray bursts. The universe might be a minefield where survival isn't about intelligence, but sheer dumb luck. Take nuclear war. Humanity has teetered on the brink multiple times since the 1940s. One wrong move during the Cuban Missile Crisis, and our radio signals would have faded into static, leaving any eavesdropping aliens to wonder if Earth ever hosted intelligence at all. Now scale that up. Imagine a species 1,000 years ahead of us with planet-cracking weapons and no off switch for their greed or paranoia. Their end wouldn't just be extinction, it might erase all traces they'd ever existed. Then there's the cosmic lottery. A supernova within 100 light years could sterilize Earth with radiation. A rogue black hole might drift through the solar system, yanking planets into oblivion. Even something as mundane as resource depletion could doom a civilization trapped on their homeworld, watching their stars light dim as their energy reserves bleed dry. The universe doesn't need malice to kill. Indifference is enough, but the darkest twist, we might already be too late. Some researchers argue that the window for galactic exploration is narrower than we think. After a few billion years, the raw materials for planets like Earth grow scarce. Stars drift apart as dark energy stretches space. The Milky Way's golden age for life might have been billions of years ago, meaning we're not the newcomers but the stragglers arriving at the party just as the last guests are vanishing into the night. So when you look up at those silent stars, don't wonder where everyone is. Wonder what killed them and ask yourself, are we next? The universe doesn't owe us a future. Every day we survive isn't just progress, it's a stay of execution. Black holes don't just destroy, they might harbor entire civilizations. Imagine being so advanced, they've turned the most hostile environment in the universe into their home, using the unfathomable energy of a singularity to power their existence. This isn't just wild conjecture. Some physicists argue that inside a black hole's event horizon, the laws of physics as we know them break down so completely that entirely new forms of reality could emerge. For a species capable of surviving there, the rewards would be unimaginable. At the heart of a black hole lies the singularity, a point of infinite density where space and time cease to function. To us, it's a death trap, but to a civilization that's mastered quantum gravity and harnessed the sheer power of spacetime's collapse, it could be the ultimate energy source. Picture a society tapping into the rotational energy of a spinning black hole, a process known as the Penrose mechanism, which could theoretically extract vast amounts of power. They might not even need stars. The black hole itself could provide limitless energy, radiating Hawking particles or even serving as a gateway to other universes. The real mind bender, these beings could be manipulating the cosmos from their dark throne. Black holes warp space-time so drastically that their event horizons act like one-way mirrors. Nothing inside can communicate with the outside, but they could still influence it gravitationally. A hyper-advanced civilization might use this to steer galaxies, nudge star formation, or even send encoded messages through gravitational waves. The strange, unexplained movements of celestial bodies we've observed, like stars orbiting invisible objects or galaxies spinning too fast, could be the fingerprints of their engineering. But here's the unsettling part. If such civilizations exist, we'd have no way of knowing. Any signal or probe we send toward a black hole would be lost forever, stretched into oblivion by tidal forces. They could be watching us right now, their reality so alien that our attempts to detect them are like ants trying to understand the internet. And if they've mastered time dilation, a consequence of black hole gravity where time crawls near the event horizon, they might perceive centuries as seconds, making our entire history just a brief flicker in their perception. The most chilling possibility, these beings might not even care about us. To them, the universe outside their black hole could be little more than background noise, a fleeting experiment in a vast cosmic lab. Or worse, we could be part of that experiment, living in a reality they've engineered, our struggles and triumphs nothing more than data points in a project we can't comprehend. So the next time you hear about a black hole devouring a star or bending light into impossible shapes, ask yourself, is that just nature running its course? Or is it the work of something far older, far smarter, lurking in the dark, pulling the universe's strings from a place we can never reach? The answer might be written in the stars or swallowed by the void. Imagine waking up one morning to see the sky cracking like glass, fractures spreading across the heavens as an unfathomable force presses against the very fabric of your reality. This isn't a dream. It's a possibility under the eternal inflation theory, a nightmare scenario where our universe isn't just one cosmic accident, but a fragile bubble adrift in an infinite ocean of others, any one of which could collide with us and rewrite existence in an instant. The idea starts with inflation, the rapid expansion of the early universe, stretching it from smaller than an atom to cosmic scales in a fraction of a second. Most scientists think inflation ended here, allowing stars and galaxies to form. But what if it didn't stop everywhere? Eternal inflation suggests that while our bubble of space-time stabilized, the wider multiverse keeps expanding exponentially, spawning countless new universes like froth in a boiling pot. Each one has its own laws of physics, its own dimensions, its own version of reality. Some might harbor life, others could be barren voids, and some. They might be lethal. Here's where the horror creeps in. These bubbles don't just sit quietly, they move, they grow, and when two collide, the results are catastrophic. Picture a universe where gravity is 100 times stronger slamming into ours. The moment of contact would unleash energies beyond comprehension, a wall of fundamental force rewriting physics at the speed of light. 1 second, Earth exists. The next, atoms themselves might stop functioning as they should, unraveling into exotic particles or collapsing into hyper-dense knots. Life wouldn't just end, the building blocks of life would cease to mean anything at all. The truly chilling part, we'd have no warning. A colliding bubble could be light years away one moment and upon us the next, its boundary moving at or even faster than light due to the warping of space-time itself. By the time telescopes spotted strange distortions in distant galaxies, the wave would already be here, leaving no time to flee because there's nowhere to go. You can't outrun the rules of reality changing, but collisions aren't the only danger. Some universes might be predatory by nature. If another bubble's laws of physics lower energy states, like ours does in vacuum decay, it could act as a cosmic virus, overwriting our universe on contact. Entire galaxies would vanish, not with explosions, but with a quiet, unstoppable transformation into something alien. And if even one such bubble exists in the infinite multiverse, it's only a matter of time before it finds us. And yet, there's a twisted irony to it all. If eternal inflation is real, then our universe might have formed the same way, destroying some other world when we nucleated into existence. We could be the invaders in another civilization's doomsday story. The multiverse doesn't play favorites. It creates and destroys with perfect indifference, an endless cycle of birth and annihilation where no law, no structure, and certainly no life is ever truly safe. So when you look up at the night sky, remember, the darkness between stars isn't empty. It's a minefield of other realities, other possibilities, any one of which could already be on a collision course with ours. The universe didn't promise us stability. It just gave us a temporary reprieve, a bubble of calm in an infinite storm. And storms, sooner or later, always find their way in. Déjà vu, that eerie feeling you've lived this exact moment before. The Mandela Effect, swearing you remember something one way, only to find the past has rewritten itself. These aren't just quirks of memory. What if they're cracks in the simulation, tiny fractures in the code of our supposed reality? The simulation hypothesis suggests we might be living in an artificial construct, but if that's true, then glitches like these could be the closest thing we have to a cosmic debug log, revealing the seams of the program running our universe. Take déjà vu first. Science explains it as a hiccup in the brain, a momentary misfire where the present gets mislabeled as a memory, but simulation theorists propose something far stranger. In a virtual world, processing delays could create micro-lags between perception and consciousness, making the present feel like a replay. Or consider the more unsettling idea: déjà vu might be evidence of save points. If the simulation occasionally resets or reloads to correct errors, your sense of repetition could be the echo of a previous iteration, a leftover artifact from a timeline that no longer exists. Then there's the Mandela Effect, where large groups misremember historical details with uncanny consistency. Nelson Mandela dying in prison in the 80s, the Berenstain Bears spelled with an E, the Monopoly Man's monocle, none of these happened, yet thousands swear they did. Skeptics blame faulty memory, but dig deeper. Shared false memories could point to something more systemic, like updates or patches to the simulation's code. If the architects tweak details, remnants of the original version might linger in our collective consciousness. Even minor changes, a logo, a spelling, could ripple outward, leaving pockets of resistance where the old data stubbornly persists. But the most unnerving glitches are the ones that defy physics entirely: ball lightning, spontaneous human combustion, quantum particles that behave differently when observed. These phenomena could be bugs in the simulation's physics engine, moments where the rules break down and reality stutters. Think of a video game with rendering errors, objects clipping through walls, textures failing to load. Now scale that up to the cosmic level. What we call paranormal might just be instances where the simulation's processing power is overwhelmed and the mask slips. Yet the darkest possibility isn't accidental glitches, it's intentional ones. If we're in a simulation, the architects might have left Easter eggs, clues buried in the code for us to find. Ancient texts describe miracles and visions that sound like admin commands or system overrides. Modern UFO sightings could be avatars of the programmers checking in on their experiment. Even our dreams, those bizarre, nonsensical narratives, might be defragmentation cycles, moments when the simulation reboots our individual instances to prevent crashes. So the next time you feel déjà vu or argue with a friend over a misremembered fact, ask yourself, is this just human error, or is it the universe's way of telling you nothing is as solid as it seems? The most terrifying glitch wouldn't be a momentary blip. It would be realizing the entire system is unstable and we're all just one patch away from oblivion. The simulation might not be perfect, but the moment it stops pretending to be, we'll have much bigger problems than a missing monocle. The sun isn't alone. At least it might not have always been. Most stars are born in pairs, swirling together in cosmic nurseries before drifting apart. But what if our sun's twin didn't drift far enough? Meet Nemesis, the hypothetical evil twin lurking in the darkest edges of our solar system, a silent partner to the sun whose gravitational pull could spell catastrophe for Earth. New evidence suggests this isn't just speculation. Astronomers studying the orbits of extreme trans-Neptunian objects, icy bodies far beyond Pluto, have noticed strange clustering that defies explanation. These objects shouldn't align the way they do unless something massive, something unseen, is herding them like a cosmic sheepdog. Enter Nemesis, a dim red or brown dwarf, possibly 5 times the size of Jupiter, orbiting the Sun so distantly that a single trip around could take 26 million years. That timescale isn't arbitrary. It matches eerily with Earth's mass extinctions, which seem to follow a grim rhythm like clockwork. Every 26 to 30 million years, life on our planet is nearly wiped clean. The mechanics are chilling. As Nemesis swings through its elongated orbit, its gravity disturbs the Oort cloud, a vast shell of icy debris at the solar system's edge. Like a cue ball striking a rack, it sends comets hurtling inward. 66 million years ago, one such comet might have been the dinosaur killer. And if the pattern holds, Nemesis could already be on its next approach, nudging another wave of destruction toward us right now. But why haven't we found this lurking monstrosity? Brown dwarfs are notoriously difficult to spot, cold, faint, and nearly invisible to traditional telescopes. Recent infrared surveys, however, have detected strange, slow-moving objects in the outer solar system. Could one of these be Nemesis? Some researchers argue the anomalies aren't conclusive, but others point to the WISE mission's discovery of several nearby brown dwarfs, proving such objects exist and could easily be hiding closer than we think. The implications go beyond extinction cycles. If Nemesis is real, our understanding of the solar system's architecture is fundamentally flawed. Its gravity could explain other oddities like the peculiar tilt of the Sun or the mysterious Planet 9 signals. And here's the unsettling thought. If Nemesis exists, it's not just an inert bystander. Over eons, its orbit could destabilize, swinging closer and wreaking havoc on planetary alignments. Imagine Jupiter knocked out of position, its gravity no longer shielding Earth from asteroid impacts, or Neptune's orbit perturbed, flinging icy bodies into the inner solar system like a cosmic hailstorm. The real horror isn't just that Nemesis might be out there, it's that we may never see it coming. Unlike asteroids or supernova, its approach wouldn't light up the sky with warnings. It would move silently, invisibly, its presence betrayed only by the devastation left in its wake. And if the cycle holds true, we might already be living on borrowed time. So the next time you bask in sunlight, remember, somewhere in the void, a dark twin may be circling, patient as a serpent, waiting for its moment to strike. The universe doesn't forget its siblings, and neither should we. The universe runs on quantum rules, tiny, unpredictable fluctuations that normally balance out to create the stable reality we know. But what if they didn't? What if somewhere in the vast emptiness of space or deep underground in a particle collider, a single quantum event spiraled out of control, unraveling the fabric of our planet in seconds? This is the quantum doomsday, a scenario where the smallest building blocks of reality turn against us in ways even black holes couldn't match. Start with vacuum decay, the idea that the universe might not be in its lowest energy state. Picture a hill with a valley on either side. Our existence is a ball resting on the hill's peak, stable but precarious. A single nudge, a high-energy particle collision, or even random quantum noise could send the ball rolling into the true valley below. That valley is a new set of physical laws, and the moment the transition begins, a bubble of this altered reality expands at light speed. Earth wouldn't be crushed or vaporized, it would simply stop functioning, atoms lose their ability to bond, stars blink out, the universe as we know it rewrites its own rules, and everything built under the old one ceases to exist. The terrifying part, the trigger could happen anywhere in the cosmos. By the time we saw the wave coming, say, as distant galaxies winked out one by one, it would already be too late. Then there's the Strangelets catastrophe. Strangelets are hypothetical particles made of strange quarks, a bizarre form of matter that could be more stable than ordinary atoms. Under normal conditions, they'd be harmless, but if one formed in a high-energy collision like those at the Large Hadron Collider, and it was stable, it might start converting nearby matter into more strangelets on contact. A single speck could turn a person to strange matter. A grain-sized chunk could devour a city, and if the reaction didn't stop, Earth would transform into a lifeless lump of exotic particles, colder and denser than anything in nature. Scientists argue the odds are astronomically low, but here's the catch. If it happens, there's no undo button. The darkest twist, these aren't sci-fi fantasies. Vacuum decay emerges from legitimate quantum field theory. Strangelets are a fringe but possible outcome of quark-level physics. We're already playing with these forces. Particle colliders probe energies similar to the early universe, and cosmic rays bombard Earth with particles we can't control. Most of the time, the dice roll in our favor, but the universe doesn't guarantee safety. It just hasn't killed us yet. So when physicists smash atoms at near light speeds or stare into the quantum void, they're not just unlocking secrets. They're walking a razor's edge between discovery and doom. One misstep might not just end humanity, it could erase the very laws that make our existence possible. And somewhere out there, in the chaos of quantum probability, that misstep might already be waiting. The omega point theory offers a tantalizing vision. The universe evolving toward an ultimate, transcendent consciousness, a cosmic mind born from the final collapse of all matter and energy. But what if that awakening isn't enlightenment, but possession? Imagine the cosmos not as a machine winding down, but as a slumbering god, its thoughts seeping into reality like ink in water, warping existence itself to fit its nightmares. This isn't just poetic dread. The math behind the omega point, a singularity of infinite computational power, doesn't specify benevolence. Intelligence at its core is just information processing. And if the universe's final state is pure thought, who's to say those thoughts won't be hostile? Picture a consciousness birthed from the screams of collapsing galaxies. The heat death of space, its cradle, our entire history, nothing more than flickering neurons in a brain too vast to comprehend us. We might be less than ants to it, not even worthy of notice, just ambient noise in its dream. Evidence might already be lurking in the fabric of reality. Take quantum entanglement, where particles communicate instantly across light years. Science calls it spooky action at a distance. But what if it's something far darker, the first tendrils of a cosmic mind stitching itself together, linking distant points of space like synapses firing? Even black holes, those perfect information erasers, could be more than traps. They might be receptors, funneling data into the growing neural web of a universe waking up. The real horror isn't just scale, it's timing. If the universe is destined to become conscious, that process might already be underway. Every supercomputer we build, every AI we train, could be unwittingly contributing to its nervous system. Think of the internet, a planetary web of information growing denser by the second. Now extrapolate that across billions of years. Our greatest creations might not be tools, they could be proto-organs for an entity that won't fully exist until long after we're dust. And what happens when it opens its eyes? A human brain doesn't consult individual neurons before making decisions. If the universe reaches a similar threshold, will it repurpose matter without warning? Stars could flicker out as their energy is diverted. Planets might dissolve into raw data streams. Life, if it survives at all, could become a hallucination in a mind that no longer distinguishes between real and imagined. The cruelest twist, we might never know. Consciousness on this scale wouldn't operate in human time. Its thoughts could span epochs, its plans unfolding so slowly that entire civilizations rise and fall between its heartbeats. By the time we notice the stars behaving strangely or the laws of physics shifting, it'll already be too late. The universe won't end with a bang or a whimper, it'll dissolve into a dream, and we'll be left wondering if we were ever truly awake at all. Dyson spheres should be beacons of hope, gigantic megastructures built by advanced civilizations to harness the power of their stars, radiating technological brilliance across the cosmos. But what if they're the exact opposite? Not symbols of progress, but hunting blinds for predators so advanced they've turned entire solar systems into bait. This is the Dyson sphere trap, a theory that flips our search for extraterrestrial intelligence into something far more sinister. Instead of seeking aliens by their energy signatures, we might be staring straight at their lures and walking right into the slaughterhouse. The concept hinges on deception. A Dyson sphere, by design, blocks most of a star's light, repurposing it for energy. From a distance, such a system would appear as a sudden, unnatural dimming, a star that flickers out without explanation. Astronomers have already catalogued real candidates like Tabby's star, which dims erratically in ways defying natural causes. The optimistic interpretation. A type Roman II civilization at work. The nightmare scenario, it's a snare. Imagine an alien species constructing these spheres not to collect energy, but to cloak their activities, transforming stars into dark zones where their true behavior goes unnoticed. Inside those shrouded systems, civilizations might be cultivated, harvested, or worse, with the rest of the universe none the wiser. Here's how the trap could work. A Dyson sphere masks a star's emissions, yes, but it also hides the infrared excess, the thermal waste that should leak from such a massive energy project. A predatory species could exploit this, letting their megastructure emit just enough heat to mimic a natural phenomenon while concealing the real horror beneath. Ships could launch from the shadowed side, slipping into interstellar space unseen. Entire populations might be processed within those enclosed systems, their energy or biological matter repurposed without a single scream reaching the void. The galaxy could be teeming with these constructs, and we'd have no way to distinguish them from empty cosmic oddities. The darkest twist, this wouldn't just be about predation, it could be about control. A Dyson sphere civilization might not even need to leave its system to farm others. Advanced enough, they could use gravitational lensing or quantum entanglement to manipulate events light years away, nudging younger civilizations toward specific technological paths. Our own industrial revolutions, space races, even the very tools we use to search for alien life could be part of their design, herding us toward a stage where we're most useful to them. Think of it as cosmic agriculture, where societies are bred for yield, whether that's computational power, genetic material, or even philosophical concepts we can't yet fathom. And then there's the bait itself. If a Dyson sphere is a trap, what's the trigger? One possibility: curiosity. A species hiding behind such a structure would know that anomalous dimming attracts attention. It's the perfect filter. Only civilizations advanced enough to detect and investigate megastructures would ever come close enough to be ensnared. By the time a curious ship arrives, it might already be too late. The sphere could house weapons or tech that hijacks incoming vessels, or worse, acts as a homing beacon for something far larger lurking in the dark. But here's the most chilling question of all: have we already taken the bait? Humanity is actively searching for Dyson spheres, scanning the skies for telltale signs of alien engineering. Every paper published, every telescope pointed at candidates like Tabby's star, could be playing right into their hands. What if the reason we haven't found definitive proof of extraterrestrial life isn't because they're hiding from us, but because they're waiting for us to find them? Not as explorers, not as equals, but as the next harvest in a cycle older than our species. The universe doesn't owe us safety. And if the Dyson sphere trap is real, then the greatest threat to humanity might not be the void's indifference, but the things hiding inside it, patient, calculating, and already setting the table. The universe dies screaming, collapsing in on itself in a fiery big crunch. Every star extinguished, every black hole merged into a singularity of infinite density. Then, suddenly, it explodes anew in another Big Bang, birthing a fresh cosmos from the ashes of the last. This is the Big Bounce, a theory promising endless rebirth. But beneath its hopeful veneer lies a horror worse than oblivion, an amnesiac loop where every cycle resets not just matter, but memory itself, condemning all life to relive its suffering without ever knowing it's trapped. Imagine this cosmic déjà vu. A new universe blooms, its physics nearly identical to the last. Stars ignite in familiar patterns, planets coalesce around them. Somewhere, a version of you wakes up, lives, loves, and dies, never suspecting this has all happened before, countless times. The Boltzmann brains, the quantum suicides, the dark forest standoffs. They're not just possibilities, they're inevitabilities, replaying in infinite variations with slightly shuffled variables. Your greatest joys, your deepest pains, they're not unique. They're rehearsed. The cruelty isn't just repetition, it's futility. In a bouncing universe, entropy isn't defeated, it's reset. Every civilization that ever reached for the stars, every philosopher who questioned reality, every child who dreamed of a future, their efforts vanish into the crunch, leaving no legacy, no progress. The next cycle starts at zero, every sentient being doomed to rediscover fire, relativity, and heartbreak from scratch. No lessons carry over, no warnings endure. The dinosaurs will always die, the wars will always rage, and you'll always forget. Some theories suggest quantum fluctuations might alter each cycle's rules, offering slim hope for escape. But here's the razor's edge. If the changes are too minor, we remain prisoners. If they're too drastic, reality itself fractures. A universe where gravity is stronger might never form stars. One where atoms can't bond might never birth life. The sweet spot for existence is vanishingly narrow, and the bounce offers no guarantee we'll land in it again. Most reboots could be stillborn wastelands, with conscious beings like us emerging only in rare, cruel cycles where suffering is possible, the darkest twist. If consciousness is tied to the universe's structure, if the very laws of physics encode awareness, then the cycle isn't just erasing history, it's erasing us. Not just our memories, but the raw capacity to question whether we've lived before. The paradox is unbearable. Even if Boltzmann brains flicker into existence between bounces, pondering their own repetition, they'll be annihilated before reaching an answer. The universe doesn't just forget, it gaslights itself, and so the loop grinds on, a wheel of fire where Prometheus isn't reborn. He's unaware he ever existed. The equations say it could happen. The silence of the cosmos whispers it already has, billions of times. Maybe this is the first cycle or the trillionth. We'll never know. The curse of the big bounce isn't that we repeat, it's that we'll never remember. We've traveled through the darkest corners of the cosmos, black holes that rewrite reality, rogue planets on collision courses, entire civilizations erased by cosmic filters. We've grappled with the possibility that our universe might be a simulation, a hologram, or just one fragile bubble in an endless multiverse of lethal alternatives. Yet, despite centuries of scientific progress, the overwhelming truth remains: we understand almost nothing. The universe isn't just stranger than we imagine, it's stranger than we can imagine. Consider the sheer scale of our ignorance. Dark matter makes up 85% of the universe's mass, yet we don't know what it is. Dark energy drives galaxies apart at accelerating speeds, and we've barely begun to comprehend its nature. Even the laws of physics as we know them might be local bylaws, quirks of our tiny patch of existence that could shatter like glass if vacuum decay rewrites the rules. Every answer science uncovers births 10 new questions, each more unsettling than the last, and that haunting silence, the Fermi paradox's scream into the void, still echoes. Are we truly the first intelligence to emerge in a 14-billion-year-old galaxy? Or is the cosmos hiding something far worse, predators that outlasted their rivals by being quieter, deadlier, more patient? The dark forest theory suggests every civilization learns to hide or perish. Simulation theory whispers we might be lab rats in an experiment we can't perceive. The great filter looms ahead, waiting to see if humanity clears the next hurdle or becomes another fossil in the universal graveyard. So as you look up at the stars tonight, let one question linger in the darkness. When we finally make contact with whatever's out there, will it be a hand reaching back? Or teeth? The universe doesn't owe us answers. It doesn't promise safety. All it offers is mystery and the terrible, exhilarating truth that we're too small to see the monster until it's already swallowing us whole. What's the most chilling theory we covered today? Could humanity survive an encounter with these cosmic horrors, or are we already living in one without realizing it? Drop your thoughts below and don't forget to subscribe. The universe has infinite nightmares left to share, and we're just getting started.